Okay, if I want to find the inverse of this function, if you remember, inverses, the domain and range are flip-flopped. And what that means is if I have an equation, I'm going to flip-flop the x and the y first thing. So where I see the f of x, I'm going to write x. And where I see x, I'm going to write y. The next thing I'm going to do is work on getting y by itself. So I'm going to add 4 to both sides. And then to keep getting y by itself, I need to get rid of the 1/3. And so I'm going to multiply by 3 over 1, or just plain old 3. And when I do that, I have to multiply the entire left-hand side by 3, not just part of the left-hand side. So on the right-hand side, 1/3 and 3 over 1 make 1, so I just have y. And on the left-hand side, I have 3 times the quantity x plus 4. If I use the distributive property, we get 3x plus 12. And then the final step to have the inverse equation is just going to be to write it in inverse notation. And inverse notation is f with the little -1 that looks like an exponent of x equals 3x plus 12. So f inverse equals 3x plus 12. Okay, when we have a table and we want to find the inverse of the table, if we're not going to make an equation, we just have to remember that the domain and range of the function is reversed when we have inverse functions. So my x values and my f of x values are just going to switch places. And instead of putting f of x in my table, I need f inverse of x. So I'm going to use that inverse notation. And then I'm just going to write my ordered pairs flip-flopped. And that is all. The last topic in this video is going to be composition of functions. If we take a look at this example here, we have g of h of x. So what this is telling us is that we need to replace x with the entire function h of x into the g function. So I'm going to take h of x and I'm going to plug it in for x and g of x. So I've got 4 times x plus 3y plus 8. And then I just need to simplify 4x plus 12y plus 8. And that is going to be the composed function g of h of x.